Okay, today we are going to talk about the distance formula and how that is derived from the Pythagorean theorem. Now, let's say that we wanted to find the distance between the points A and B that I have here. So ignore the triangle that I have drawn out for a moment. But if I just wanted to find the distance between the point A and the point B, it's going to be the length of this horizontal line. Okay. Now, since we're working on the Cartesian coordinate plane, we can do some pretty nifty things to find this distance. I did draw out a right triangle, and the way that I drew this out is I just I drew a point that was at the x coordinate of A and the y coordinate of B, and that gave me this point C. Okay, and then I drew a vertical line from A to C, and I drew a horizontal line from B to C. I technically don't need to find this coordinate first. I could just draw a horizontal line all the way down till a vertical line all the way down until I get to B, or a horizontal line all the way over until I get to the A. So once I draw this out, I end up with this right triangle. And we know how to solve the length of a hypotenuse in a right triangle. We use the Pythagorean theorem, which says that a squared plus b squared equals c squared, where a and b have to be legs of the right triangle. So this is going to be considered a leg, this is going to be considered a leg, and c always has to be the hypotenuse, which would be this. Okay. Now, another way to think about this in our Cartesian coordinate plane is our vertical distance is going to be what we consider A here, right? And our horizontal distance is going to be what we consider B. Now, in the Cartesian coordinate plane, you can find distance if it's on a grid line pretty easy. Usually you just count up, as long as it's a nice, neat number. So we can count from the distance of leg A is going to be 1, 2, 3, 4, 5, 6. Which over here I've written down that y1 minus y2 equals 6. Now, y1, that means the y coordinate of point 1. And y2 means the y coordinate of point 2. Now, I also put absolute values around these. And the reason why is because absolute value makes negative numbers positive, and it keeps positive numbers positive. And when we're talking about distance, we really don't say, oh, I live -3 miles away from the grocery store. We always talk about it as a positive measurement. So we want to keep these positive so everything's still making sense. But if I take the y coordinate of here, which is 2, and I subtract this y coordinate, I subtract 4, so 2 minus -4, well, that's the same thing as 2 plus 4, because you're minus and a negative. And 2 plus 4 equals 6. So see how it comes out to the same number? So we're going to do the same thing to find the length of B. I can count it. I can say, well, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, which is what I have written here, that x1 minus x2 equals 8, or the x coordinate of 0.1 minus the x coordinate of 0.2 equals 8. And we could look at that from here. So our x coordinate of B is 9. Our x coordinate of C is 1. So 9 minus 1, well, that equals 8. So that's making sense. Okay. Now, using our Pythagorean theorem, we could then do a squared plus b squared. So a is 6, and we square it, and b is 8, and we square it, and we're going to end up with 100 after you put that into our calculator. So I'm just going to grab my calculator really quick. And we'll do 6 squared is 36, and we're going to add 8 squared. And so we're going to end up with 100. Okay. Now, when I take a square root of 100, because we don't want c squared, we want to know what c is, we're going to end up with 10, because square root of 100 is 10. Now, it's the same thing that we're going to do with the distance formula. So the distance formula I have written up top here. It says that x1 minus x2 squared, which we said was rb, plus y1 minus y2 squared, which we said was our a. Then we take the square root of it, just like we took the square root of 100 at the end, because we're not looking for c squared, we're looking for c, and that's going to equal our distance. It's the same formula, it's just written differently, and it gets a little bit, it looks scarier this way, but it's the same idea. Now, the usefulness of using the distance formula like this instead of the Pythagorean theorem is actually when your points do not fall in nice, neat coordinates. So if I moved my point B, so now it's not falling on the grid lines, then my distance between the points on the the horizontal distance and the vertical distance, they're no longer something I can count easily. So the Pythagorean theorem by itself isn't really going to help me because I can't just measure that distance there. You're going to have to use a little bit of algebra. Okay? And so I would have to do that in order to find what the actual distance is. All right. I hope that this video helps explain where the Pythagorean theorem, where the distance formula came from, how it relates to the Pythagorean theorem, which might help you remember the distance formula because you do have to have that memorized. And yeah, just let me know if you have any questions. I will talk to you later.